Hello all, welcome back. So let's look into the today's lead code problem, number of provenance. Okay, so the question is that problem statement is that there are n cities, some of them are connected and some are not. Okay, if city A is connected directly with city B and city B is connected directly with city C, then city A is indirectly also connected with city C. Okay, got it. A province is a group of directly or indirectly connected cities and no other cities outside of the group. Okay, you are given a matrix and into n matrix is connected where okay each index each element I and j will show that I city is connected with j. Okay, if the I city is connected j is one, it is connected, and else it is not. Written the total number of provinces. Okay, it's a kind of similar kind of problem like a number of islands. Means suppose there are some cities like this one is connected to two, so this is one province, and there is one more city third three, so there is, if there is no connection in between two, there are two provinces. If there is one more city, it is four, which is directly connected with this, and there is one more city five, it is connected with this, then there is two. But somehow there is one more provenance, that seven, it is connected with five and it is connected with four both, then there is one group, whole one group which is connected together. That means from city 1 we can reach 3, and from 1 we can reach 5, either in directly or either in indirectly, so it will be called as a one provenance, kind of a number of island thing. Like there is a some islands, and surrounding that there is filled at water, so like number of islands are connected, like this island 1 and this one is also island 1. It's kind of similar problem. So we'll look into the problem statement, how can we iterate over this. So for that first basic approach comes in my mind is that we'll iterate over this whole matrix, is connected matrix, and uh, for each connected city we'll push the coordinate in the coordinates of that city in the matrix. Okay, and after that start iterating over the, means start it doing bfs for all cities, all connected cities, and to the next connected city, and while iterating just count the number of cities we can reach. Okay, and in the same order we will maintain the, what we going to maintain, will maintain the count of number of provenance. Okay, let's look into that the problem statement, how can we solve it. First I have to create a stack, or either stack or either queue, we can use any of them. So uh, here I am using queue. Okay, queue of type, so I have to store two indices, means ith index and the jth index. So for that I am using here queue of pair of int comma int. Connected city. Okay, now we'll iterate over the whole number of is connected matrix. For loop int I equal to 0, then is connected dot size, whatever the size of this matrix. Then now here I have to check if is connected of I and j. Then what I have to do, I have to push that coordinate in the q q dot push. What I have to push here, I comma j, whatever the coordinates here I have to push it here. And now what I have to do, I have to maintain this order, like there is coordinate for 1, 1, 2 and 3. Okay, these two cities, three cities, and 1 and 2 cities are connected. So it's a matrix. How it will be look like? One city is connected to two. So let's take this kind of 1, 2, 3 like this, and we'll take one more. Sorry, and this one also 1, 2 and 3. So this 1 and 1 is connected. Yes, it is connected. 1 and 2 connected. Yes, it is connected. 1 and 2 is also connected. Now 1 and 2 and 1, 2 and 1 also connected. Yes, it is connected. Now this 3 is connected with this 2, 2 connected. Yes, it is connected. 1 3 connected. No, it is connected. No, else rest of them are 0. So we have to taken care of two elements like this. This same indices. So we have to taken care of I should be if I is equal to j, we have to take that coordinate, because I also connected, city 1 is connected with city 1, so we did not take care this city 2 and 2 combination, either 2 comma 1 and 1 comma 2. So we have to taken care of both of combination. Okay, so we'll look into that, how can we take care of both. So while updating the visited matrix, will handle the second scenario. Okay, so and here I have to, like when I creating a queue, so while creating a queue, now what I did, I push this element, first element, like this 1 cross 2 I pushed, then I pushed 2 cross 1, 2 cross 1 is also connected, then I after that I push 3. Okay, so to make a difference in every element, I have to make some difference in that. So for to making this kind of difference, I am going to push -1 and -1, like that, -1 -1, so that I can found there is a difference. Okay, so it will be help me to count the number of provisions. Okay, so while pushing this, after pushing this, what I am going to push in this, so this instance, connected city instance is created here, so using that instance here, the similarly will push invalid index also, this dot push -1 comma -1. Okay, and here if I, here directly I am going to handle the both condition also. I is not equal to j, this is also condition. Okay, only then I am going to push. If I is not equal to j and it is connected, only then I am going to push. After pushing, what I have to do, I have to first I create a one matrix. So to do matrix for visited, to count that it is it visited or not. Okay, to check that I in previous iteration I checked the particular city or not. Okay, so for that visited city of which size I have to take. So for that, here I am taking some variable of int n, which is equal to, and we are also given that it is n cross n matrix. So here I am taking the size of this. Let's copy, paste on size this. So every time when I want to use the size, so directly will use this n. Similarly n. Okay, is it clear? So here I am creating a 2D matrix of size n cross vector of int of size n cross, and it will initialize all elements starting from 0 that currently I am not visited. Taking one variable and count provisions. Count provinces is initialized with 0. Okay, while this connected city, and we have to do BFS until this connected city don't become empty, is not become empty. Until that we have to do this. So while iterating, first we have to fetch the coordinates. Okay, so how we going to fetch? And remove that first coordinate from that. Now I have to check. What I have to check is it if 1 and y equal to -1. If both are -1, then we have to handle the next one state. So for handling the next one state, what I have to do? I have to check what I have to check here. Tell me. So I will check, is the size, is it become empty or not? If it is become empty, then I have to continue. If this is it empty, then continue. Okay, if it is empty, then I have to continue. If this if it is if then we'll check for next city, and here we'll check the is it connected or not. If city at yy, if it is visited, then also we need to pop it out and then continue. First pop dot pop and then continue. Okay, else if it is not visited, then what we have to do? Come down. If it is connected city, continue. If it is connected city, then front, then we'll also continue. If it is not connected, if it is visited, then okay, then we need to continue. Else what we did, we have to count these provisions. Okay, count plus plus. Okay, so we're going to count the provisions here. It has become empty. So what we're going to just push the invalid index first, so that it will first find the invalid index. If it is invalid, then we'll check the next occurrence. Then the next occurrence, if next city is valid, and if it is not visited only, then it will update. And after update, what it needs to do, it needs to continue. Okay, and then in the last I have to do simply just go next. But here there is one problem, that there is it is working in such a, this queue is working in such a way that first in first out, so we cannot do in such a using this queue. So for that we have to use stack here. Stack pair of int and int connected city, and integer of it is connected is size. Then I have to update also logic. So first I push -1 -1, then I push this one. So here I have to update the logic. Control X. The first one logic is okay with the, if I am using the stack. So in the last it will be -1 -1. Okay, it is empty is front. Instead of front we'll need to use top. If it, top element is this -1 -1, then we have to check is it our list of city is become empty or not. If it is become empty, then we need to continue. If this is city of front, then else we have to fetch the front element. Front means from the top next city we have to fetch from the stack. Okay, then we'll check is that city is connected or not. If it is already connected, then we have to pop it out. Okay, we will going to pop it out that city and continue. Else what we need to do, going down and count the provisions. Okay, here and continue. Okay, now what we need to do, we have to just what we need to do here, we will going to update like this, for x and y means, if there is a column, so like this, if there is a matrix is there. Okay, if there is a matrix, so I am, suppose I am on this index, this ith index, I am on this index, and this is pointing to I comma j. Then what I have to do, I have to check other cities which is connected via I, and other cities which is connected via j. Okay, all of this. So I have to iterate in this order also, and I have to iterate in this order, both. So what I have to do, I have to take for loop int I equal to x comma I is less than n equal I plus plus. Okay, oh sorry, I have to start it from 0, sorry. And there is a condition, if the same condition here is follow, copy and paste. So for that, here I equal to 0, I less than, and I plus plus. I is not equal to 0, I both should be not equal to 0, and we have to check it is connected or not. If it is connected, then we have to push both I and j, then we have to push -1 -1. Okay, so what's the next here? So we'll initialize this j pointer with, so from which element we have to initialize the j? First from I, first from x, then we'll initialize from y. Okay, here we are initialized from x, so we'll follow the first column, this one column will follow this one, iterate for this one. Okay, first we'll iterate for this. So while iterating, push all of this, then we'll iterate it again, copy paste. I equal to 0, again I equal to 0, I less than, and I plus plus. Now in this case what we have to do here, we have to iterate over j j plus plus, and the int I, which is initialized by y. Okay, so to make this all of this in correct order, we'll initialize j with y and I with x. Okay, it will work fine, and in the end we have to return number of count provisions. We'll return this, return this one. So can we check is there any error or not, or we'll try to run. Yes, there is some error in line number 22. Here instead of comma we are using this instead of and. If x is this and y is this, only then we have to come in this loop. Okay, it is invalid, then also then we need to update the provisions. Okay, it is showing we are having TLE. Okay, let's look into the code in which condition we are going in the TLE state. Okay, we did not handle the is connected state. Okay, got it. Because when it is connected, it is top. Okay, here we are handle the invalid state, and while iterating also will handle the connected city that we already visited this, so we'll pop it out. Now here also while iterating, we have to handle this I and jth column also. If if x and y is already connected, then we did not handle this part because it is already connected. If visited city of x and y is not connected, only then we'll go in this loop. Okay, so after visiting we have to update this e barabar 1, and the same is again equal to 1, initialize with 1. So here it will be y and x. So we have to check it here is not. Similarly, when we are going to push, before pushing we have to check is it connected or visited or not. If I and j city, if this, yeah, if this city, if visited city is not visited, only then we'll going to iterate over this further I and j. Okay, similarly we'll check it for here if it is not visited. Okay, now we'll resolve the TL state, but we are getting wrong answer. We are having 1, but we are expecting 2. Let's look into our approach where it is making issue. So there is 1 1 1 1, and this one is 0 0 1. Okay. So what's the mistake here we did? For city 3 we ignore the city 3 here. How we are ignoring this? Using this condition, if I is not equal to j, you using this condition we ignore this city. So we have to just check it is connected and not. I and j city is connect. If it is connected only, then we have to push that city because it will maintain the count of each city, else it is connected or not. Okay, provenance is there, then x and y. If it is invalid, then We'll check next city. If it is empty, then continue. If not empty, then check the next city. If it is next city is connected, then we'll also need to continue. Pop it out and continue. If it is the else we'll need to update the provenance. If it is city is connected, okay. So still having this wrong answer. Okay, for this it is counting three times. Okay, it is counting three times. Mm, why it is counting three times? Think for a while why it is counting two times. It is counting three times because of we handle each city separately. Because of this we are adding here this condition, so we have to remove this one also from here. So it's working fine. Let's try to submit it. Check is it failing for any other test case or not. So it's working, but the solution is not that much optimized. Let's first rethink of our approach. Can we do more optimized on this approach or not? So what we did, we push all the nodes in it. So instead of this, can we, instead of pushing all the nodes, can we push only those node in it, means only n nodes in it, not all connected node. Instead of pushing all connected node, just push only the nodes which is separate node. Can we add this condition? If I equal to j and this, so it will just minimize our approach little bit. Yes, it is also working fine. So similarly, can we make it little small over here? No, we cannot, because from here we have to reach all the connected nodes. We'll check is it, no, still it is having the same issue. Okay, we'll check the optimized code, what they are doing. Okay, this connected city, and here they are DSU, this disjoint set they are using. Dating if it is connected and j, then they are disjoint union by side and j. Okay, and count while find they are here, they are finding the pairs, number of pairs I and j equal to I. Okay, they are using some kind of disjoint pairs. Okay, fine, we'll wrap it here.